Welcome to the video where I'm going to show you how to run a Minecraft server on Docker. And then we're also going to use Docker Compose to build a Docker Compose file to deploy our Minecraft server that way. There will be a link in the description to a GitHub repository which has all the information to everything we're going to do in this video, including the Docker Compose file. This is just part one of a series that I am calling Running Minecraft in Production. My goal with developing this series of videos is to, one, help people run Minecraft in a more predictable manner, but two, also help people who are interested in the cybersecurity, software development, information technology careers get an understanding of some of the concepts and the tools that we use within the industry. So let's get started. This first video is all about installing Minecraft on Docker and teaching you how to use Docker to get a Minecraft server up and running. So we're going to be using Docker Desktop for Windows in order to do that. There are a few things you're going to need to follow along with me. So if you go to docs.docker.com/desktop/install/windows-install, or you simply Google how to install Docker Desktop on Windows, you will be brought to this page. And there are a couple of system requirements that we need to take note of here in order to download Docker Desktop on Windows. First and foremost, we need to have WSL installed, or we can do a Hyper-V backend. In this video, I'm not going to do a Hyper-V backend. I'm going to do WSL. I'll show you how to install that real quick. So if you prefer to use Hyper-V backend, you're on your own for getting that installed. So let's check out some of these. So we'll come back to WSL, but we need Windows 10 or 11 64-bit Home or Pro versions, and they need to be 21H2 version or higher, or Enterprise or Education 21H2 or higher. So if you're wondering, how do I figure out if I meet those requirements? What is my version of Windows? Great question. Let's go and figure that out. So if you come to your search bar and you search for settings and you click on settings, it should bring you to system here. And then you can go ahead and go to about. And this will display information about your PC. So we can see that I am on Windows 11 Home, which is a compatible version for Docker Desktop. And I am using version 22H2, which is larger than the required version of 21H2. It's a higher number, so I meet those requirements at least. And we can also see we need a 64-bit processor, at least 4 gigabytes of system RAM, and BIOS level hardware virtualization support must be enabled. Now these first two are easy. Again, we can go back to our about and we can see, installed RAM, I have 32 gigs. I meet that requirement. System type, 64-bit. If you don't have 64-bit, I would be surprised. That's very rare these days. The only tricky one that is going to be a little bit of a headache to figure out maybe for you is the BIOS level hardware virtualization support being enabled or not. I would suggest you just attempt to install Docker Desktop, and if it fails, you'll probably figure out pretty quick that this is the problem. They have a link here for troubleshooting this, but essentially, if it is not enabled, you will have to go into the BIOS settings of your PC and enable that. And that is different for every BIOS, different motherboards. Check your documentation. And then lastly, download and install the Linux kernel package update. We don't have to do this. If you're following along and installing WSL with me, or you already have WSL installed, this more than likely won't become a problem. But if you end up hitting issues, go ahead and click the link and begin troubleshooting. So let's go ahead and install Linux on Windows with WSL. If you cannot do this and follow along, you're probably going to have to create a virtual machine, a VM, and install a Linux operating system and not use Docker Desktop, but use Docker CLI. And I'll be showing you the Docker CLI commands so you can also follow along if you don't have Docker Desktop. So it's pretty simple. If you go ahead and we just open up a PowerShell terminal here. So I'll open up PowerShell. Let me make that a little bigger. If we look at the documentation, it gives us one command, WSL-install. So I'll go ahead and I will copy that, and then I will take that over to my PowerShell terminal, simply paste it and install. Now you can see for me that WSL is already installed, but if it wasn't, it would simply give me a few prompts, and then as long as I had the correct permissions on this computer, then it would simply install WSL. And then once it is installed, you can simply come to your search bar and you can search WSL to open a Windows subsystem for Linux terminal. Now, I think it should be noted that if you are doing this on a computer at like your school or a public library, or your parents maintain this PC and you don't have administrative rights, you may get permission denied when you attempt to install WSL. In which case, I am sorry, but you probably will not be able to follow along. And by default, the Ubuntu distribution will be installed, and I suggest you stick with that for the remainder of this series. But if you do WSL-L-V, you can see exactly which version is installed. Now, there are instructions on changing those versions if you prefer, but just know that you may run into issues that are not covered in this video series. Once you've verified that you meet all these prerequisites and you've installed WSL, it's time to start running Minecraft on Docker. So before we get started, some of you may not be familiar with what Docker is. And Docker is a platform that helps us build, run, and manage containers. And what is a container? What does this mean to you if you don't know what a container is? Great question. Well, a container is a standalone executable package that includes everything needed to run an application, such as its code, runtime, system tools, libraries, settings, etc. And it provides a consistent and isolated environment in which to run that application. You may be familiar with a virtual machine, a VM, right? And this is normally something that has to virtualize hardware, has to virtualize the entire operating system and kernel and run on what's called a hypervisor, which sits on top of another computer, right? If you were to install VMware and put a VM on it, you need to virtualize the hardware and the OS and the kernel and run that on the VMware hypervisor. A container, by contrast, doesn't need to virtualize hardware, nor does it require a hypervisor, and it shares the host OS kernel. And this difference between VMs and containers makes containers very resource efficient and portable, and a popular choice for many applications you interact with on the internet today. So the first step to running Minecraft on Docker is to install Docker itself. We'll be installing Docker Desktop for Windows. Go ahead and click on the Docker Desktop for Windows button here, and that will go ahead and download the Docker Desktop installer.exe, which will show up in your downloads folder. From your downloads folder or your browser, go ahead and click on that Docker Desktop installer.exe file. That should open the install wizard for Docker Desktop, and you can choose to add a shortcut to your desktop or not and hit OK, and you'll see all these files unpacking, and that's normal, and it's installing Docker Desktop. Now, if you've got WSL installed, you will end up seeing this screen and not be prompted for anything. If you get prompted to choose WSL or Hyper-V, if you're following along with this video, you should choose WSL, but if you're using Hyper-V, use that. So I'll go ahead and hit close, and Docker Desktop is installed. Now, you may also be prompted to log out of your computer and log back in, or reboot your computer. That's normal. If you're prompted for that, go ahead and do that. So now that Docker Desktop has been installed, you can go down here to the search bar and you can search for Docker Desktop, and you go ahead and open that up. I'll go ahead and accept. And then it wants a little bit of information about you. I'm just going to go ahead and skip this. And then I am logged in currently because I had this installed earlier and then I uninstalled it for this video. You will be prompted to log in. Go ahead and make an account real quick. It's free. You don't have to pay anything. You just need an email address, make a password, and then you can go ahead and log in on the Docker Desktop application. So let's browse around a little. Let's see what we got going on in here. So this is Docker Desktop, and notice I'll open a PowerShell terminal, right? And I'll put this over here. Yeah, let's make it fit on the screen. That not only has Docker Desktop been installed, but now Docker CLI has been installed. So if I run the command docker ps, which is a command that will show me all running containers, it will return something because Docker CLI is installed along with Docker Desktop. And bonus, and we'll go over this later, Docker Compose is also installed with Docker Desktop. So if you look around here a little bit, they've got some learning stuff like what is a container, how do I run a container, stuff like that. Let's go ahead and stop and delete that. So that's under the Learning Center. If you wanted to pause the video and learn more about Docker and containers, this is where you would do so. If we explore the left here, we've got containers, we've got images, right? There's that image from that Learning Center I just clicked on. I'll go ahead and delete that. We've got volumes, dev environments, and we'll go over what some of these mean. Containers is essentially which containers are running on Docker Desktop. Images is which container images have you downloaded and are stored on this machine. Volumes, which volumes are mounted to your containers to store data, right? So we'll go over these, don't worry. So now we're ready to start running Minecraft containers on our Docker Desktop. But before we can do that, we need a container image. And a container image is essentially that package around the application with everything it needs to run. So if we come over here to images, we can see that we have local images, and these are images that exist on our computer. And then we have hub images, and these are images that we have personally uploaded to Docker Hub to our namespace. And your namespace will be named after your Docker Hub username, for the account you created. So mine is the sudo, and I haven't updated any. And so real quick, if you want to go into your web browser, search for Docker Hub, log in with those credentials you made, right? You'll be sent to your Docker Hub repository. And then if you just click on Docker Hub, this is a public location where people can upload container images, and then you can download them for use with Docker for free. So if I wanted an Nginx container, it's in here. If I wanted MongoDB, Node.js, right? Python, all these containers are out here for you to use. So in order to get our Minecraft image to run our Minecraft container, we can hit here, search images to run, and that'll bring us to the top bar, or we can just click on the top bar. And we're going to search for itzg Minecraft server. And this one right here is what we want. Now let's pause. What are tags? What is poll? And what is run? So a tag is essentially a version of the container image. For our video, we're going to use the latest, but in the future, if you wanted to use a different version, this is what a tag is. Poll, what this would do is it would pull this container image down to my local PC, but it would not run it. And then run would actually pull it down to my local PC and then run it. So we're going to hit run first, and it might take a few seconds for it to populate this page because it is pulling the container or downloading the container to our local PC before it'll display our options. And here's where we can name the container that we want to run. So we can call it Minecraft, and then ports. So ports in Docker and containers are a mapping of host system port to container port. So here we can't change this port, right? This container is going to be exposed on port 25565 TCP, but we can choose which port on our computer that this Docker container is mapped to. And just for usability, ease of use, I'm going to use the same port, 25565, but this could be any port. And in the future, if you wanted your friends to connect, this would be the port on your network that you would forward the traffic through in your router to. We're going to skip volumes and environment variables for now, but we will get to them in a minute. Once we populated the name and the port, we'll hit run. And now we can see it's beginning to run our Docker container, but if we hit this arrow here, we can be brought to the main page. Let's click containers. Here we can see all of our running containers and their statuses, their health. And we can see that the one we just ran had exited. Now, why did it exit? Well, if we click on it, right, we get these logs, and we can see that we need to accept the Minecraft EULA. And now, for those of you following along on Docker CLI, if I do a Docker PS, I have no containers running, but I can do a Docker PS-A, which will show me all containers, even the exited ones. And I can see my exited Minecraft server now. And if I wanted to view this log using Docker CLI, I could grab the name of my container, which is Minecraft, and I could say Docker logs Minecraft. And now I can see the logs and why that container exited in the first place. So I just showed you this commands that map to what we're doing over here on Docker Desktop. So how do we pass in the command to accept the user end license agreement? Well, to do that, we'll go ahead and head back to containers here. We will click on the trash can to delete it. We'll go to images and we'll go ahead and find our Minecraft server container and we'll hit the run button. And we'll fill in the name again. I'm going to call it MC just for short because it's going to make this whole process go a lot quicker later. 25565 report. And now environment variables. What do we put here? How do we know which environment variables to use in our containers? So if we actually go to Docker Hub and we search for the container that we're using, it's CG Minecraft server. You can see that they have a click here for documentation button. So I'll click on that and that'll bring me to the documentation for this Docker container. So generally, whoever creates the container image that you run is the one that decides what variables you get to pass into that container. And now we can see here the Docker run command for the Minecraft server image has a variable specified by the flag -e EULA equals true. All right, and we can also click on variables here on the documentation and we can search for EULA, right? And it says that this must be true. So we have to pass this in order for our Minecraft server to start. So we'll go back to Docker Desktop and we'll specify the variable EULA and the value has to be true according to our documentation. We'll hit run. And now we can see we're getting further than we did before. So we're downloading our Minecraft server and this will probably take a few minutes. So while that's running, let's look over here in Docker CLI, Docker PS to list the running containers. Our MC container, Minecraft, is running. We can Docker logs, MC, we can see these logs. If we want to watch these logs in real time, we can say Docker logs MC-F, right? And that will, the -F will show us the continuous running output. And then we can hit Control-C to exit that, Control-L to clear your screen. There's some Linux tips for you people out there new to Linux. And we can inspect our Docker container here in the Inspect tab. This will show us all the environment variables. This will show us our data mounts, our volume mounts, which we'll go over in a minute, and ports. And it looks like I forgot to bind my port to 25565 there when I hit run. We can enter the terminal, which puts us into our Minecraft container. So we can run things like archon-CLI and do whitelist commands. We can look at the files within the container and we can view some stats on our container. So I'm actually going to delete this real quick because I did not bind the port earlier, so I won't be able to connect to my Minecraft server. I'm going to relaunch it. Again, we'll say MC, we'll say 25565. We'll say EULA true. And we'll hit run. All right, so once we see Archon running, that's how we know we can probably connect to our Minecraft server. So I'm going to go ahead and spin up the Minecraft launcher and attempt to connect to my Minecraft server. Now you want to make sure that the version that you pick on your Minecraft launcher is equivalent to the version that you launched the Minecraft server container with. So I know that the latest Docker container version is 1.20.1, and it even says here in the logs starting Minecraft 1.20.1. So I'm going to pick 1.20.1 and hit play. I'll go ahead and hit multiplayer and I will add a server. And I'll call this Minecraft Docker. And the server address is going to be local host. And then that port we mapped or bound our container to on our PC, which is 25565. I'll hit done and we will log in. I'm joining my world and you can see I'm in, and then you can also see that Baja Blastoise has joined the game in our Minecraft server logs. So I'll disconnect. So the equivalent Docker CLI command to run a container is docker run. And then I'm going to pass a flag -d. And this stands for detached, meaning if I run my Docker container, please run it in the background, detach it from my current terminal session, right? And I'll show you what happens if we don't pass -d, and you'll see why it matters. And then I'm going to pass --name, and this will be the name of the container. So I'll call this MC2 because container names need to be unique. Right now we already have MC running, so I'll do MC2. If you don't name it, naming it is not a requirement. It will get a random name like Big Castle, Little Cat, something like that. We'll do -p, and we'll pass the port mapping. So this will be this first will be the system port. So the port on your computer that will map to the port of the container. Now we're already using 25565 on our local computer. We cannot use the same port for multiple applications. So I'll do 25564 colon and then 25565 because that is the container that Minecraft will be exposed on. Then we'll pass -e, which will be for environment variables. We can pass as many -e's as we want, but for now we only need to pass EULA equals true to accept that end user license agreement. And then finally we need to pass the actual namespace and container image name as it exists on Docker Hub. So we'll do it_minecraft-server. And then I'll do colon and then the tag. So I'll do latest. I want latest. By default, if I don't provide a tag, I will get latest. So I'm going to pull that and you'll see this. And now we have our second Minecraft container running, and we can see it over here in Docker Desktop as well. And we can inspect it. You know, it's 25564. We accept the end user license agreement, all that good stuff. Now I'm going to delete this second one because we don't need it. Okay, so now we've got our Minecraft server running on Docker, and that's all well and dandy. Now we need to go over volumes. So you can see that we have a volume here. If I click on it, we can see that it belongs to our Minecraft server latest container, and the target is /data. So this target means that there is a directory within this container named /data, right? So if I go into this container terminal and I cd to the root and do an ls, I can see that /data is a directory, and this contains all of my data for my Minecraft server within this container. The problem with this is that this is ephemeral in that if this container disappears, all of the data within the container also disappears. So if I connect to my Minecraft server right now, build some things, put it in my inventory, and then this container, for whatever reason, crashes and gets deleted or replaced, all that data goes away. It's the equivalent of your computer getting wiped clean. So how do we prevent that? How do we make our data persistent? Well, we do that through volumes. If we go to the documentation page for this Docker container, they have a section called data directory, and this explains how all the data within the container data directory is set up. And they tell us we need to attach data to our host directory somewhere on our computer. And they give us the command -v, which is a flag you can pass to map or mount a volume on your PC to a volume within a container. So let's go over how to do that. So here on Windows, I've got Windows Explorer open. If you don't know what that is, just type Explorer, File Explorer, and then pick a place on your computer you want to store your Minecraft data. For me, I'm going to put it in one of my hard drives, the F partition. I'm going to hit New Folder, and I'm going to call it MC Data, short for Minecraft Data. So it's an empty folder. And if I click up here, it shows me the actual path on my system to this folder, which will be useful in a minute. So let's delete our running Minecraft container. And then let's go to images and let's rerun this container. Again, we'll call it MC. will map to 5565. And now under volumes, we need to provide the host path. So I will provide my f:/MC data, and then the container path, which we know is /data from the documentation. Again, we'll pass EULA true, and we'll run. And now what we're going to see is we're going to see my MC data folder on my computer is starting to populate with all of my Minecraft files. So now what's going to happen is if I log into Minecraft, I create a bunch of stuff, I have stuff in my inventory, and then I come in here and I delete this container, none of my data will get deleted because the data is being hosted and written and read to and from my Windows PC now. The only way I'm going to lose my Minecraft data is if I lose this hard drive or if I lose my actual computer. And this will become useful to us when we start doing mods. And then if you're interested in running this on Docker CLI, we can do this same Docker run command like we did earlier, but now we can pass an additional flag -v. We can say f:/MC data /data. So we're saying the path on the local host and the path within the container that we want to map it to. So let's go test our volume. So I'm going to go ahead and again launch Minecraft. Make sure I'm on the same release as my Minecraft server. Play. Multiplayer, and we're going to connect to that same Minecraft Docker container. All right. And so what I'm going to do is I'm going to fill my inventory with a few things here because we want to make sure that we can test data persisting. Okay, so I've got 5 sand blocks in my inventory. So I'll go ahead and disconnect. And then I'm going to go ahead and delete my Minecraft server. Delete forever. Yep, it's gone. So my Minecraft server is gone. But notice my data is still intact on my Windows machine over here. So I'll go to images and I'll relaunch this and I'll say MC to 5565. Host path will be f:/MC data mounted to /data / in the Minecraft server container. Variable EULA is equal to true, and we will run. So we are recreating our Minecraft server, reinstalling it. And once it's up, we will reconnect and see if our 5 blocks are still in our inventory. So let's see if we can connect now. I'm logging in, and there we go. My 5 blocks are still in my inventory. Therefore, I know that data has persisted across server destroys. So quick recap, what did we do so far? So we installed Docker Desktop. We installed a Minecraft container image on Docker Desktop. We ran that container. We configured it with different environment variables to accept the end user license agreement. And we also mapped a file system on our local computer, MC data, to the data directory within the Minecraft container so that our data would persist in case our Minecraft server exploded. Okay, so as you might have noticed, constantly, destroying this container and then going to images and then rerunning it and providing all of these different ports and volume paths, environment variables, this can get very tedious very quickly, right? And then over here, constantly providing Docker run commands, adding these different environment variables, right? If we've got 20 of them, this isn't very efficient, right? So how do we make that more efficient? Well, we do that with something called Docker Compose. So how do you get Docker Compose? Again, it's installed with Docker Desktop on Windows. If you're on Linux and Mac, if it didn't come with your Docker Desktop, you can install it through Package Manager. You can run Docker Compose to check if it's installed, but I'm willing to bet that if you're following along with me, it is installed. So to get started, I'm going to be using Visual Studio Code for this. I prefer editing code files and configuration files in Visual Studio Code because it is my IDE of choice. Now, if you don't have Visual Studio Code, I highly recommend you install it. And if you refuse to and you have your own IDE or you just want to use Vim or Notepad, more power to you, go ahead. But I'm going to be using Visual Studio Code. I'm going to open Visual Studio Code. Over here on the left under Explorer, I'm going to open a folder, and this can be a folder anywhere on your computer. You can make a new folder just for this. I've created one called mc-docker, and I'm going to select that folder. So now I am working out of this folder. So I'm going to right click new file, and I'm going to call this docker-compose.yml, short for YAML, yet another markup language. And then over on the documentation for this Docker container, the creator was nice enough to provide us with a basic Docker Compose file to get us going. So we'll copy that. I'll come back over here and we'll paste that. So version, that's a Docker Compose thing. You don't have to worry about that. That has nothing to do with Minecraft. Services. So this is where we define all of the services that we want running, because typically containers are referred to as services or microservices. So we say we want the MC service running. If I change this to Minecraft, and then we define an image. What image would you like this service to use? And we're going to say the itzg/Minecraft-server, the one we've been using. We'll keep TTY true. We'll keep standard open true. For ports, this is where we're going to add our port mappings. If we had more than one port, we would add them here like so, right? But we only have one, so we'll keep that just like that for now. Environment. So this is where we provide all of our environment variable key value pairs. So we provide EULA is the key and the value of it is true. And then volumes, this is where we can define the volume on our PC that we want to map to the /data directory within the container. So I'm going to edit this to be my f:\\mcdata. And there we go. So now I have written a Docker Compose file, and this is the equivalent of what we were running earlier in Docker Desktop and in the Docker CLI. But now we've written this configuration into a file. So I'll go up here and I'll open terminal. And this is just going to open a PowerShell terminal within VS Code right here below my file. Makes it easy to work so I don't have to keep switching back and forth between PowerShell and VS Code. And just make sure I'm in the right directory with my terminal, yes, because my Docker Compose file is in here. Now I can run Docker Compose up -d. -d stands for detached. Remember, oh, you know what? I thought I told you I would show you what happens if you don't use -d with Docker run. This is what happens, right? So Docker Compose is creating my configuration the way I've defined it. And you can see I'm just kind of stuck here. I can't do anything in my terminal because it's been taken over by the logs from this Minecraft container. So I'll hit Control-C to cancel that. Right, and that'll kill my Docker Compose stack. But that is what happens if you don't use -d. So now if I run Docker Compose Docker Compose up -d, as long as I'm running this from the same place my Docker Compose.yaml file exists, I don't have to provide the path to my Docker Compose file right here. Now, if your Docker Compose.yaml file is in a different directory than the one you are running Docker Compose up from, then you need to provide that path to that file. So we'll run Docker Compose up -d, and there it says running container MC Docker Minecraft 1 started. So I can do a Docker PS and I can see that it's running. I can come over here, Docker Desktop, and now I see this little kind of like layers, stacked layers symbol, which is different from this container symbol because this is a Docker Compose stack. Because typically with Docker Compose, you deploy multiple containers at once, right? You would define multiple services here, whether that's 2 or 20. And when you run Docker Compose up, they all come up at once under the same stack. So now this is running, and it should be attached to fmcdata, and it is. All right, and we're going to be using Docker Compose later to also launch our Prometheus and Grafana containers along with our Minecraft container. Okay, so now I want to tell you about restarting. So what happens if something goes wrong with this container and we're not around to spin up another container or restart it. And then all of our friends have to wait for us to get home from work to restart the container, right? We have a solution to that. So let's go ahead and actually delete this stack right now. Now, I just deleted the Docker Compose stack. You could also do Docker Compose down in this directory, and that would also stop the stack. So you may notice a theme here. There's multiple ways for us to do all these things between Docker Desktop, Docker CLI, and Docker Compose. So we're going to add what's called a restart policy to our Docker Compose file. Below volumes, we're going to add restart, colon. Then we're going to specify on-failure, colon 3. So what we're specifying here is a restart policy. If our container fails, how many times should we attempt to restart it before we give up? And we're going to specify 3. So I'll save, and I'll do a Docker Compose up-d. That'll bring us up. So now we're going to comment out with the pound symbol our environment section. So our environment and our environment variable. And this is because if we don't pass the EULA, our container will fail to start. And then I'm also going to come over to my MC data directory, which is mounted to /data within the container. And we've got this file called EULA. And this means this is where whether or not I have accepted the end user license agreement is being tracked. Now, because this is persistent, I'm going to go ahead and delete this. So now when I start my Minecraft container, because we're not accepting end user license agreement and I deleted that file saying I accepted it at one point, the Minecraft container should fail to start and it'll attempt to restart 3 times before giving up. So let's Control S, save this, do a Docker Compose up-d, and let's watch this. So we should see this go from running to restarting 3 times. Exited. So that was really quick, but here was our initial start, and it didn't work, so it failed. And so it tried it 1, 2, 3 times, just like we instructed it to. So if we update this to 4 and do a Docker Compose up, real quick, we see it restarting. 1, 2, 3, and 4. And the initial 1, 2, 3, 4. So that is a restart policy. If your container fails for whatever reason, it will attempt to restart that many times that you specify. And if you don't specify the amount, it will just attempt to restart forever. So let's set our environment back to the way we want it. I'll set this on failure 3. Let's Docker Compose up. I'm accepting the end user license agreement now, so this shouldn't be failing anymore, but I just wanted to demonstrate what a restart policy is. And then the equivalent Docker CLI command to adding a restart policy on a Docker Compose file is -- restart flag, and then how you want to handle restarts. And we're doing on -failure. And then if you look at the actual documentation for restart policies, these are your options. Do not restart, on failure, which we just went over, always, and unless stopped. So that's it for part 1 of my series running Minecraft in production. Part 2 will be how to install mods in your Minecraft container so you can run a modded Minecraft server on Docker.